Hello, my name is Camilo, and this work titled Uncovering Library Features from API Usage on Stack Overflow is in collaboration with Eleni Constantinou and Kurt de Robert. It is common to find in current software development the usages of third-party libraries. So, for example, in this code snippet, you can find underlined in red the usages of the JSON library. Now, this JSON library is part of a larger software ecosystem called Maven, where several libraries are grouped together and can be categorized into several applicability domains, such as aspect-oriented, actor frameworks, collections, and so on. Now, from the collections category alone, 72 libraries target this specific domain. And in the software ecosystem, you can find a ranking based on the usages of these libraries and a brief description of how are these libraries as well basically described. Now, from this brief description, it's not enough for the developer to see what are the main features of a library. And probably from this brief description, they can extract that some of the API features of a library is related to collections such as sets, stacks, queues, and maps, and so on. But other features, high-level features, are missing. Like, for example, are these libraries persistent or thread-safe? What are the methods for sorting? What are the methods for reversing? And how to filter a collection, how to transform a collection, and so on and so forth. In a more high-level scenario, how are these features used is also lacking from these rankings. For example, are these features single method calls or a group of method calls? Do you need to instantiate certain classes, or is enough with the static calls? And finally, how these libraries do compare between each other feature-wise. This information is lacking and from the current rankings. And previous work have been in this direction. For example, the works of Antoniol and Wehenuk, where they propose that the feature is a set of data structures like fields and classes and operations such as functions and methods participating in the realization of a functionality. Also, Kanda and colleagues propose that the feature is nothing more than a set of API calls with a corresponding name. We also, in this paper, we subscribe to this definition, and for us, a feature is nothing more than a set of API calls or a single API call subscribed to a name. Our source of information to extract or to potentially extract features is Stack Overflow, because you can find the usages of several libraries there, and also natural language information associated with this usage. And this is basically our approach, and I'm going to briefly describe the major steps of this approach. First, you select a library, for example, Guava, and from this library, we extracted the jar files of each of the versions present in the Maven software ecosystem. Now, for all of these jar files, we apply the Apache Visual Library in order to extract the public interface of these libraries, meaning the class and method names from the public APIs. Now, this is the information present in the software ecosystem, and we also extract the information present in the Stack Overflow, and for that, we rely on the name of the library present at least in one of the tags of the post in Stack Overflow, and we queried the public dataset SO to extract this kind of information. In the end, we extracted the question ID, titles, tags, and the body of the questions and the body of the answers as well from this from a Stack Overflow. Now, with this information, we discarded those posts without any code snippet, and for those posts with code snippet, we extracted the code fragments, and using a custom implementation of an island parser, we extracted the API calls in these code fragments. Now, we match this information against the information that we had before from the software ecosystem to see if these usages are indeed belonging to a set, belonging to a particular library. If that's the case, like in this case is extracted, we then consider the natural language information around this usage. Now we classify this information into two main categories. The first one, the textual information, englobing or containing information such as the post titles, the body of the questions, and the body of the answer. And finally, and then the other category about API usage information is basically the code containing the method names divided by the camel case style that is common in the Java language, and the API calls, meaning the classes followed by all of the methods that are belonging to this class. We extracted similarity matrices because we wanted to see if there are similar usages and potentially some features. And in the case of the textual information, we use the TF-IDF model and a consign similarity between each of the posts that we are able to extract. And in the case of the API usage information, we use the Jacquard similarity to form this similarity matrix. With these similarity matrices, we apply a hierarchical clustering, and more specifically, hierarchical clustering with the dynamic threshold cutting, because we wanted to obtain the optimal clustering and not relying on a specific threshold, that this threshold is automatically selected for us. With these clusters, we wanted to see if those clusters present some APIs that are frequent, and for those that do not have this kind of behavior, we excluded them, and we rely on the local outlier factors to do this. And basically, this is an example. You see that the frequency here is not clearly depicted, is not clearly distinguished one method from another. And in this case, we discard those clusters. Now, in this other case, you see that this filter method is very, very frequently used. And in this case, because the is frequently used in comparison to other methods, and you see that this cluster is basically about the usage of this method, then is included for further processing. Now, with those selected clusters, we processed the natural language information, and we extracted pairs of nouns and verbs by relying on semantic trees. And these pairs, we also computed their frequency, and we also used the local outlier factor to finally propose a name for these clusters. Now, we wanted to check if those clusters that have names, so the final output of our approach, they correspond to features. But first, we wanted to see which of the combinations present the most cohesive clusters. So that means that we consider combinations of text attributes and code attributes independently from each other. And we wanted to see which one produces the most cohesive cluster, meaning that the silhouette score is closer to 1, denoting a strong structure or a reasonable structure. We found that the methods combination and belonging to the code attributes present the most, I mean, you can obtain the most cohesive clusters using this combination. We want also to research if the extracted features the proposed features correspond to tutorial features. And for example, we extracted cookbooks and tutorials from the libraries that we performed the study, and we compared them to the generated features by our tool. And in this case, we found that a high percentage of them were matched, and also if you discarded the information that is in our data, this match accuracy increases. Also with the high relevance, because we compare the classes and the methods that are involved in these features that are generated by our tool and the tutorial features. And on average, our uncovered features are very similar to those in tutorials using this relevance score. Finally, we wanted to see if the remaining features that our tool or approach generates, they are present in some GitHub repositories. And for that, we extracted some usages in some GitHub repositories, and we again match those usages against the features generated by our approach, and we saw that the majority of our uncovered features are also used in GitHub client projects. In this case, also the relevance was medium in average, but this is caused because the GitHub usages are less focused and they could encompass more of one of our features. Some examples of uncovered feature by our tool. These are an example of good features. For example, you see that this is related to convert images or convert PDF, and you see several methods here. Also to merge documents over here, and some bad features that our tool also produces. Like we couldn't find any applicability for this kind of so-called features. Finally, this is the link to our approach. You can access. You can make a pull request if you want to. It's publicly available, and we call them we call the tool Diffuso, and we presented this tool to another venue track. Finally, some potential application for maintainers that, for example, that rely on an approach. They can look for similar features in other libraries, looking for the uniqueness of a feature if their libraries present some unique features or some common features, and how are they compared to other similar libraries. And for users, they can also look for similar features in other libraries, but in addition, they can use our approach to document certain libraries. And finally, they can look for certain features using our tool as well. To conclude this presentation, we introduced the problem of the selection of a library by developers in a software ecosystem, and how the current rankings lack the features information about the libraries. We also propose an approach of how to tackle this problem, and we evaluated our approach against some tutorial features and against some GitHub usages. And finally, we recommended some potential applications to maintainers and users using our approach. And we presented some examples of the features, and we shared the links to our tool. So thank you so much for listening, and I'm looking forward to any of your questions.